Is my voice audible?
Yes, sir.
Students, is my voice audible?
Yes,
Is
sir.
the board is visible, right?
Yes.
Board is visible, right? So today, Tausif,
Sir.
is my voice audible for you?
Yes, sir. Yes, sir.
Board is visible? Screen
Yes,
visible?
sir. Yes, it
Okay.
is visible.
Okay. Students, today we will start the next chapter, isometric projections. So generally, now we just do the orthographic projections. So in which two or more views are going to be drawn to describe an object completely and accurately in appearance and also in size. Okay. So to visualize the shape of the whole object in its 3D form, so all the two or three orthographic views of the object have to be simultaneously and have to be simultaneously seen, and you are going to be get a conclusion. So it is to be drawn. We have to draw imagine by making our imagination, okay, about its shape. So there is nothing but your isometric projection. So each of the orthographic views shows only so two dimensions. So therefore, such a drawing can convey information only to the people who are going to be completely trained, okay, in reading the multi-view orthographic drawings. So while we are supposed to consider for this isometric projections, so this is difficult. This difficulty is overcome by giving the pictorial type of projection. Okay, so which it displays all the three dimensions in one view. So that is nothing but your isometric projection. So the main name itself, iso means equal, and metric means measure. So means so hence isometric projection means a system of projections. So equality of measure, we can call it as equality of measure. An isometric projection is a pictorial projection, so in which 3D of a solid are not only shown in one view, but also the dimensions can also be measured from it directly. Okay, so main use of this isometric projections are going to be, so pictorial drawings conveys the shape of the object in such a way that even a layman who is not familiar with the art of reading the drawing also can easily visualize its shape. Okay, so generally these pictorial drawings are used for machine or structural details, architectural buildings, pipelines, etc. So assembling and disassembling of machines and structures are also going to be seen. So it is always used by engineers in the design and development of new parts, the shapes of which are going to be difficult to understand from the multi-view orthographic projections. Okay, so isometric scale, we generally see the isometric scale also. So the isometric projection is drawn using the isometric scale, which is nothing but which converts your true lengths into isometric lengths, which are foreshortened by 0.82 times. Okay, when it is foreshortened by 0.82 times, we will consider it as the isometric scale also. Okay, students, had you understand what is mean by this isometric drawings, isometric projections? So whatever the solids, for example, while we are going to be seeing the different kinds of solids in general, so different types of solids we are going to be seen. So if these solids are going to be drawn directly, okay, so and we are supposed to make it pictorial representation. So that means or 3D representation of the object directly. So until now we see the two orthographic projections. That means two-dimensional views. That means either front view, top view, side views, like that. Okay. So those views, with the help of those views, it is going to be imagined, and we just have to understand what was the original shape is going to be complicated, and which is going to be understand by only the professional. The common layman cannot understand it. So we can also draw the pictorial representation of the given object, and he can easily understand. That means a common layman can also understand. So that should be done with the help of these isometric projections. Okay, simply you just remember this isometric projections means directly we just make it represent the three-dimensional object directly in a view. So at which your dimensions are going to be read directly from the measurements from the any of the view. Okay. So generally these isometric projections, iso means iso means to measure, and metric means iso means equal, iso means equal, and metric means to measure. So there is nothing but your isometric projections. So equal for measuring any view. Okay, an isometric projection is a pictorial projection. Projection is an pictorial in which three of the solid, in which three dimensions of solid are not only shown in one view, not only shown in one view, okay, but also their dimensions, can measure from it directly. Okay. So generally each of the orthographic views shows only two dimensions. So therefore such a drawings are going to be can convey the information only to the trained and skilled person only. Okay. So while we go for this isometric projection, this can be understood by the common layman also. Okay. So pictorial drawings conveys the shape of an object in such a way that even a layman who is not familiar about the art of reading of the drawing can also be visualize the whole thing. Okay. Generally, there was in general we also see the isometric scale also, iso scale. So which is nothing but 0.82 times, which is 0.82 times the original dimensions. So then we can obtain the isometric scale. Okay. So converse, that means original dimensions are true lengths. So true lengths are going to be converted into 0.82 times. So which are foreshortened by 0.82 times the original dimensions, which are foreshortened generally. Okay. So by using this isometric scale, generally in some of the textbooks they are using this isometric scale and construct the three-dimensional views of the object. So generally we can also take it isometric scale, or directly we can go for the two lens also. Okay. So generally what is being with these isometric drawings are generally, let us say this was the orthographic projections which we already know. For example, if it is going to be like this, front view, side view, and top view. This was the standard procedure. Always you just see this. Okay. So generally you just see this was going to be one of the side views. Side views, we have two types of side views. What are they? Right side views and left side view. So this was the solid object which is going to be seen from front view. All of you see on the bottom of front view, you just obtain the top view. All these are going to be the standard. Okay. So this was the left side view and it is the right side view. Okay, let us see the side views which are going to be. Okay, if it is going to be given in this pattern, always you just see this. Your side views are going to be beside your front view, and top view is going to be just bottom of the front view. Okay, so this should be the pattern. So this is 1, 2, 3, and 3, whatever it should be. Any of the ones side views are going to be sufficient. I just represent like this. Okay, always your front view is going to be seen from front, and it is top view is going to becomes below xy. Generally, what we are seeing, if you draw the xy, above xy it is front view, below xy it is top view. Similarly, here also it is front view, top view. Beside the front view, obtain the side view. Okay. Next, we just had to draw the isometric view. Okay. So isometric projection is nothing but your isometric projection means. So isometric projection and isometric view. So point 8. So this becomes your isometric projection. We call it as isometric projection. So when you're going to be constructed with the true lens, so it is nothing but your isometric view. So isometric view means, so constructed with the true lens. With true lens, that is nothing but your isometric view. If your construction is done with 0.82 times of the true lens, it is isometric projection. Okay. So generally the views are going to be obtained like this. So if I constructed like this, means this was going to be the isometric view. So which isometric projection. So if you just consider, it was going to be the isometric view. So this isometric drawn with iso scale, that is nothing but your 0.82 times the true dimensions. So then you are obtained isometric projections. So isometric view is going to be drawn with true dimensions. So without reducing the given dimensions. So first of all, how can we construct this isometric projection, sir? So we have the isometric scale. All of you just see. First of all of you just had to remember what is meant by this isometric scale. First of all, when you consider with horizontal, so this was 30 degrees, and this was also. This becomes isometric axis. Isometric axis. Okay, so this becomes, let us consider this is x, this is y, and this is z. With the help of this, we can construct the isometric axis. Okay, so isometric view or isometric drawing are drawn to the actual size, that is actual scale. Okay, so the lines are drawn parallel to the isometric axis, and the true lens are going to be laid off. The isometric projection is to be drawn in isometric scale, and the rights are drawn parallel to the isometric, and the lengths are foreshortened by 0.82 times, then it is going to be your isometric projection. Okay, so let us see here if it is going to be considered. Now this becomes your isometric axis. This was your isometric axis like this. Okay, so all the lines are going to be drawn parallel to the isometric axis, and if it are foreshortened by 0.82 times, then it is isometric projection. If you just consider the isometric axis and you draw for the true dimensions, that we can consider it as isometric view. So this was your isometric axis. Okay, students, is it clear? Is it clear about the isometric drawings? So generally, so this was our orthographic projection. So orthographic view means we just have only front view, top view and side view. So with the help of these, we just had to imagine this was the figure. So if it is going to be a skilled person and which are trained person, then he can understand with the help of these front view, top view and side view. But a common layman cannot understand this. So if a common layman can also understand, it should be done with the help of the isometric drawings only. So these isometric projections are going to be drawn with the help of. So that means x and y axis are going to be tilted for an angle of 30 degrees with the horizontal. Okay, and z is going to be perpendicular to the horizontal. Okay, so isometric projection is nothing but drawn with an scale of 0.82 times of the true length, while isometric view is drawn with the true dimensions. Okay. If this is a simple problem, then you can easily understand. All of you see, just draw the isometric view of the isometric view of square lamina. Lamina or plane means the same. Okay, square lamina of side 35 mm. Of side 35. When it is placed with its surface, when it is placed with its surface, first one is vertical, second one is horizontal. So before going to the construction of a solid in isometric view, first of all, we just had to know about the square lamina. What that means nothing but the plane surfaces, how it should be drawn when your plane surface is vertical and horizontal. Now let us see how it is to be. So when you vertical means, all of you just wait a second. So that means first of all, let us consider when your plane is going to be vertical. So when you consider your vertical, first consideration, so it should be either right isometric view or left isometric view. Let us see. If you just draw your isometric axis first of all, if it is going to be axis like this, so this is 30 degrees, this is 30 degrees. Okay, so if you consider your plane is going to be like this, if you consider your plane is going to, so this is also vertical. So when it is going to be seen in this pattern, if it is going to be some A, some B, some C, D, okay, so this we can call it as, when you are going to be seen in this pattern, it is right isometric view. Okay, similarly, if you draw your isometric, if your isometric axis again it is going to be drawn, from here it is 30, from here it is 30. Okay, so if you consider the vertical axis is going to be here and it is going to be, if it is going to be some here. Okay, so this is also your square plane is going to be vertical. So when you are going to be seen in this pattern, it is going to be left isometric view. Okay, so when you are, this was the first condition, vertical. So having two conditions, either you go for right side isometric view or left side isometric view. No one, there is no constraint. So both of the answers are going to be the correct. So either you consider left or right. Next one is horizontal. Horizontal means when your isometric axis or which axis are going to be considered. Let us see if your axis is going to be considered in this for vertical. Okay, if it is x, if it is y, if it is z, so here you just consider the axis of x and z. Okay, this was, if you just consider this axis is going to be, so this axis is going to be x and this axis is going to be z when it is vertical. If you consider this one, if you consider this one, this axis is going to be y and this axis is going to be z. So both xz and yz are the planes which are going to be considered your plane surface vertical. Next one is horizontal. So when your horizontal is going to be considered from this isometric axis, which is going to be preferred for horizontal, x and y are going to be preferred. Okay. So I just consider for second bit, it is going to be, if I draw the horizontal, okay, so this becomes my x, this becomes my y, x, y, okay. Similarly, from here it is going to be, we just draw a line parallel if it is A, okay, and it is going to be some B and it is going to be some C. From C, draw a line parallel to it. From B, draw a line parallel to AC. So this becomes your D. Okay, students, how do you understand? So first of all, I just consider, let us see. First of all, I just draw horizontal. Horizontal means how it should be. So which vertical axis is going to, which axis are going to be considered? X and Y. Okay, let us consider the given side is of 35. So all are going to be sides of 35. Okay, so from here let us consider my point as A. From 35 I just this becomes B. From 35 draw C. Okay, C as radius, 35 as radius draw. B as center, 35 as radius draw. You will obtain your D. So this becomes your D. Now this becomes your horizontal. When your isometric view is going to be drawn for square lamina, here it is vertical condition, here is horizontal condition. Now what are the axes which are considered here? The axes are x and it is x, y. So when you consider your x, y axis only, you will obtain your surface horizontal. When you consider x and z or y and z, you obtain your plane surface are going to be vertical. Okay, students, is it clear? Is it clear? Now let us consider draw the isometric view of a isometric 60-30 set square. Let us see a 60-30 set square with its surface parallel to VP, with its surface parallel to VP. So when your surface parallel to VP means you have to construct it is vertical. Okay, and longest edge measures 150. Longest edge measures, so let us consider it is 100 mm. So first of all, we just construct our 30-60 set square first. So first of all, the 30-60 set square is going to be obtained like this. This was going to be some AB. Okay, and let us consider it is going to be some 60 degrees. And this was some 30 degrees, A, B and C. So which is given, this was 100. So if you just given this problem is going to be like this, a 30-60 set square, the longest edge is 100, 60 and 30, I just obtain my point C. Now how can we obtain how can we do the construction? So simply make you inscribe this triangle in a box. First of all, you just have to consider this should be inscribed in a box. Okay, let us consider this box is going to be already AB some PQ. AB PQ is your box. Okay, now I know my surface is parallel means surface parallel to VP means it should be vertical only. So vertical means what are the isometric axis we have? Vertical, what was the first condition? Vertical. I can take any of the axis. So if the isometric axis is like this, first of all, this is 30, 30, X, Y and Z. So I just consider my YZ axis. YZ is going to be my axis. Now this becomes your, this is going to be, let us consider this is Z and Y. Let us consider this is going to be some B, A and this is P, Q. I know that AB are going to be one of the points. So AB are one of the points. Now let us take A as again take A as center, draw an arc. Then you obtain point C. AC as radius, A as center, draw an arc. Okay. Why? Because I constructed a box PQRS. So C point is going to be in between P and Q. So now directly take PC as radius, P as center, PC as radius, draw an arc. Or Q as center, QC as radius, draw an arc. Then you obtain so other condition is, what was the other condition? You just consider the XZ also. XZ also, then what is going to be points? This was A, P, this was P and Q. Already know AB which is equal to 100, I know that. Next, and C point is in between P and Q. So PC as radius done to obtain your C. So join P with A and C with B. Okay, so these are the two conditions for the plane surface vertical. Okay, students, in first problem I just considered. First problem, what was the isometric axis I considered here? This is Y. Sorry, this is Z. and y. While coming to here, it was z, it was x. Okay, so both the planes are going to be vertical. Students, is it clear? Students, why somewhat didn't understand the problem? Let us see. So I just had to construct my problem such a way that I had to construct this triangle on the vertical plane. What was the vertical planes we have? Vertical plane either xz is going to be my vertical plane or yz. If I consider xz, let us see xz is considered, that means you just draw the horizontal. First of all, you just draw the z, so this point, and you just draw the line like this. This becomes your x, this becomes your z. Student, let us assume this was your x, this was z. When you consider this z means you are going to be obtained, then y also consider, then you vertical. Okay. Now let us see my ABPQ is going to be the box. So reconstruct box on this axis. So that means if I consider my point is at A, this is A, and with 100 I get my point at B. If I draw the line parallel to this, if I draw a line parallel to this, and I just draw this line, so I just obtain my box ABQP. ABQP is obtained at here. Okay. So once I obtain my box, let us see AB is going to be measures 100. So this AB is 100. Next, where the point C is, I obtain AB, my point required is C. C point is in between P and Q. So P as center, PC as radius, to obtain C. So this becomes your triangle. Okay. Similarly, the same procedure you can go for YZ also. Let us see for YZ. If you just consider here, okay, this becomes A, B, this becomes A. Again, the box is constructed here. So the axis is going to, this is going to be Z, and this is going to be Y. There I can assume XZ, here I assume YZ. Okay. So AB is 100, I know that. So this was Q and this was P. So P as center, PC as radius. Why? Because C point in between P and Q. P as center, PC as radius, diagonal. So join. So this becomes your triangle. Okay, students, is it clear? Similarly, I just consider my plane is going to be hexagon. Draw isometric view of a hexagon, hexagonal plane. So here I just consider isometric view. That only I just taking the original dimensions. If you ask for isometric projection means you just multiply with 0.82. Okay. The given values are going to be multiplied with 0.82. Then you obtain isometric projection. Isometric view is nothing but to construct with the original dimensions. Plane of side 25 mm. Okay. Placed with its surface first one is horizontal, second one is vertical. Placed with its surface horizontal and vertical. So for that, first of all, I just had to construct my regular hexagonal plane of side 25 by our method. Okay. Let us consider my hexagon is going to be like this: A, B, C, D, E, F. Okay. Once you obtain your square your hexagon, you just inscribe your hexagon in a square. Okay. So this square box is going to be that once your hexagon is inscribed in a box PQRS. P, Q, R, S. Okay. Now my first condition is to be, so first of all, you know what is the isometric axis, right? X, Y, Z, which is 30 degrees, 30 degrees. Okay. So what was the axis which we consider for horizontal? First one, horizontal, which isometric axis is considered? Only X and Y. Okay. So further only I just draw my X and Y. So this is nothing but your box PQRS. P, Q, R, S. So that means you just draw a line of 30 degrees and 30 degrees to here. Mark it as some point P. From PQ, I just draw a QR draw a RS draw a, and you join obtain a box. Okay. Now let us see A point, where your A point is. A point is in between S and P. So S as center, SC as radius. Draw an arc to obtain your A. Okay. So for example, this is going to be okay. A. Next, F and E points are going to be in between S and R. So S as center, SF has radius, it becomes F. R as center, RE as radius, this becomes E. R as center, RD as radius, this becomes D. P as center, PB as radius, this becomes your B. Q as center, C. You obtain your C. Now join all the points. So this becomes when your plane is horizontal. When your plane is vertical, which axes are going to be considered? Either YZ or XZ. Any of the axes are concerned. Now we just consider YZ. Let us see. I just consider YZ. So this becomes your Q, P, S, and R. The box I just construct my box on this isometric axis, 30 degrees. Okay, and I know that A point is in between S and A. So S as center, S as obtain A. Radius, draw an arc to are in between P and as center, PB as radius, draw an arc. Q as center, QC as radius, draw an arc at center. S as center, SF as radius, R as center, RE as radius. Join all the points AB. Okay, this is going to be considered as vertical. So this we can consider as right isometric view. Okay, students, is it clear? So first of all, whatever the plane surface which we obtain, we just inscribe that plane in a box PQRS and we reconstruct our box PQRS in my isometric axis and place the points. Okay, and place the points in the respective positions of the box. Next, let us see the circular plane. Draw the isometric view of a circle. Of diameter 50 mm with its surface parallel to VP and parallel to HP. Parallel to VP and parallel to HP means parallel to VP and parallel to H means that means surface is horizontal, parallel surface is vertical. Okay, so in that case, first of all, we just construct our circle. Now divide your circle into 4 equal parts for obtaining the smooth curve. I just consider 4 parts. So that is A, B, C, D. Now again, what was the first thing we just had to do? Inscribe our circle in a box. So I draw my box such that my circle is going to be inside this box. Let us mark this as some PQ RS. And I know the isometric axis was 30 degrees, X, Z, Y. So first of all, I just consider horizontal. Horizontal means that is parallel to HP. When the parallel to HP, which axis is considered? Parallel to HP means horizontal. Horizontal is X and Y. So X and Y are considered. Okay. Now let us say I just draw my isometric axis like this. So I just consider this was going to be 30. This is also 30. Okay, so this becomes your P, Q, R, S. All of you just see. So this was very important to construct the circle. Once you know your circle also, then we move to the next solids. Okay. So we just had to follow, the method was for circle, when you just it is circle, we just follow 4 center method. 4 center method. Let us see the 4 center method at here. Okay. Now, points A, B, C, D, where your points are going to be existed. A point is in between S and P. So this becomes A. B point is in between P and Q. That means PB as radius. This becomes C. Next, this becomes D. Okay. Next, this was a 4 center method. Let us see. Now join. Let us take the 4 center method. First of all, let us take the corner P and join the opposite 2 side midpoints. That means P opposite sides are SR and RQ. Join the opposite side midpoints, that are D and C. So join P with D and join C with P. Okay. Next, take your opposite corner R and join R with A and join R with B. Students, okay? So join, first of all, join P with C and D. Next, join R with A and C. Now this becomes your centers. So this is O1 and this is O2. Okay. Now O1 as center, OD as radius, draw an arc. O1 as center, OD as radius, or O1 as center, OA as radius, draw an arc. Similarly, O2 as center, OC as radius, draw an arc, or O2 as center, OB as radius, draw an arc. Next, P as center, PD as radius, P as center. Okay, let us see O1 as center, O1 D as radius, draw an arc. Next, O2 as center, O2 C as radius, draw an arc. Next one is P as center, PD as radius, draw an arc. Next, R as center, RA as radius, draw an arc. Okay, P as center, PD as radius, draw an arc. Next, R as center, RA as radius, draw arc. Okay, then you will obtain your ellipse like this. Students, is it clear? Now let us see when your plane is vertical. So that means second condition. So when it is vertical, which axes are going to be considered? When it is vertical, so that means vertical means parallel to VP. So that means which axes are going to be considered? XZ or YZ. Okay, I just consider X and Z axis, X and Z are considered. When you consider your X and Z, let us see. So I just draw my second bit. So it is isometric axis. Okay. So this becomes my box P, Q, R, and S. Okay. So when you consider your box P, Q, R, S, P, Q, R, S. So when you consider your PQRS, let us see the point where the point B is existing. So B point is going to be existing in between P and Q. So P as center, PB as radius, you will obtain the point B. Next, A point is in between P and S. So let us take P as center, P as radius, draw an arc. Similarly, I obtain my D point and I obtain my C point. Okay. Now the same procedure. What was the same procedure which we done? So I just join the corner. Okay. So P is going to be taken as center. I join P with D and P with C. Similarly, I join R with A and R with B. Now, what are the two origins we are obtained? This becomes O1 and this becomes O2. Okay. When you see your O1 and O2 is obtained, now O1 as center, O1A as radius, draw an arc. Similarly, O2 is obtained, O2B as radius, draw an arc. Okay. Once you obtain these two arcs, remaining are going to be this was one center, this was one center. Two centers are completed. So this was the another two centers. So P as center, RA as radius, close the arc. Then you obtain your point. So centers are nothing but what are the four centers? So this method is nothing but your four center method. What are the four centers? O1, O2, P, and R are going to be the four centers. Okay. Now O1 as center, O1 A as radius, draw arc. Similarly, O2 as center, O2 B as radius, draw an arc. Next one is P as center, P as center, PD as radius, draw an arc. Next one is R as center. Next R as center, RA as radius, draw an arc. So this becomes your condition vertical. Okay. So make it fast. Is it clear, students? Clear? Students, can I erase this? Had you copied this? Can I erase? No? వాళ్ళు ఏమైనా స్క్రీన్ షాట్ తీసుకుని నేను Students, can I erase this? Can I erase this problem? Okay. Now let us move on to the solids. So let us until now we just see the planes. So let us move on to the solid, how it is going to be appeared in the projection of a simple square pyramid. Let us square prism. Let us see. Draw the isometric view of square prism of side of base 35 mm and axis height is 65 and axis height is 65 mm. When the axis is perspective, it is axis is vertical, second one is horizontal. So what is our isometric axis? We already know isometric axis is going to be XYZ. So in this problem he just gives it when your square is going to be square prism is going to be vertical, when your square prism is going to be vertical and one it is going to be horizontal. So that means he doesn't give the square prism is vertical and horizontal, he just gives the axis is vertical, axis horizontal. When your axis is vertical, means when your base is going to be resting on HP, so then only the axis is vertical. When your axis horizontal, when your axis is going to be parallel to both the reference planes and your base face is going to be vertical, then it is to be the condition. So let us see here, first condition is axis is vertical and axis is horizontal. So first of all, let us see your simple position of the square prism. So let us see the top view gives the true shape of a square. Okay, so top view is the true shape of a square. Given of side, let us take the given side 35. Okay, so this is A, B, C, D, in bracket it is P, Q, R, yes, okay. So this was your axis. So height of the axis is given. So what was the height of the axis which is given? Which is 70. Height of the axis is some 65, right? So base side is given as 35. So let us see. So front view. Let us see the front view which is going to be obtained like this. Okay. What are the front view points? Top base is visible, right? So this becomes P dash of A dash and this becomes C dash of D dash. Similarly, it is Q dash of P dash bounding. Next, it becomes R dash of S dash. So this becomes your O1 dash. It is your O2 dash. So this was the simple position of the solid. When your base is going to be on HP and axis is vertical. So let us see how it is going to be constructed in isometric view. First of all, I just constructed my isometric axis. What is my isometric axis? Isometric axis, when your base is horizontal, which axis is considered? X and Y are going to be considered. Okay. X and Y are going to be considered. Now let us see, these points are going to be, let us see, the points are going to be, which points are going to be on the top, which are going to be on the bottom. So on the bottom it is going to be some PQRS points, right? Okay, so this becomes some Q. This is R. This is S. And it is P. Okay, if it is going to be like this. Now, this was your bottom base of the solid. Let us see, this was the bottom base of the solid. Okay, this was the bottom base of the solid PQRS. This is ABCD, right? So when you construct for isometric axis, this PQRS is going to be obtained like this. This is 30 degrees. This is 30 degrees. Next, in front view, you just see the height of the solid. What was the height of the solid? Which is 65. So you simply project all the points to the 65. Okay, let us see. This was 65. So let us see, if you just consider this was going to be 65 and here it is going to be some 65. Okay. Once if it is going to be 65, you just join these points. So again it going to becomes like this. Okay. So from 65, what are the consecutive points for B? It is going to be Q. It is going to be QB. And here for S it is going to be SD. For P it is going to be A. For R it is going to be C. So this was your construction. Okay. So if it is going to be comes like this, then it is these two corners are just joined in my construction. If it is not going to be joined, so what are the visible edges? So I just see this all edges are going to be visible like this. Okay. So when you are going to be seen in this pattern, what are going to be? This is going to be visible. This is visible from front. So this becomes your invisible. The base edges like this. When you are going to be seen in this pattern, what you are going to see, this edge is seen, this edge is seen, these 3 points are going to be seen, and these 3 edges are going to be seen. Okay. So here it is going to be, up to QS is going to be seen. Remaining this was going to be the seen like this. This edge is going to be seen like this. Okay. This is the condition for when your base. First one, it is axis is vertical or base parallel to HP. Okay, students, is it clear now? Students, is it clear? Okay, shall we move to the next condition? Had you copied this? Students, had you copied this? Students, had you copied this? Shall I erase it? Okay, this condition is completed. The next condition is when your axis is going to be horizontal. So when your axis is horizontal means then the base surface becomes vertical. Let us see if this is the condition. Axis is vertical, bases are horizontal. When your axis is horizontal means bases become vertical. These are vertical. Then what are the vertical axis which we consider? I just consider my YZ. Okay, let us consider YZ. us consider your corner is going to be resting as going to be the bottom is going to be, let us see some, this is R, this is Q, this is P, and this is S. Now let us consider this is 30 degrees, right? Next it is going to be extended. So this one plane is going to be obtained. So when your base is going to be like this, I obtained this. I had to extend for again all the edges for given 65 height. Okay. So I just draw again the line of 30 degrees. So this measures 65 and this measures 65. This measures 65. Okay. So from here it is going to be like this. From here it is going to be vertical. Okay. When you consider that edge is going to be like this. Okay. So I just consider it, these edges are going to be just coincide. So for your original construction, these may not be coincided. So these points are going to become A, B, C, D. Okay. So this is nothing but your condition is axis is horizontal or base is vertical. Base is going to be vertical. Students, is it okay? Is it clear? Shall I erase it? Had you copied this? Can I move to the next problem? Tausi, okay. అసలు మ్యూట్ అయిందిలే చూసాను. Okay, students, is it clear now? So first of all, I just put my simple position of the given solid, so which is going to be drawn like this. So base is resting on HP, such that your axis is vertical. So top you gives the true shape of the hexagon. So and it is a prism. I obtained two set of points A, B, C, D, E, F, and P, Q, R, S, T, U, V. So top base points are going to be, so this is O1 dash, this is O2 dash. Top base points are A, B, C, D, right? So this becomes A dash. So this becomes B dash of F dash. This becomes C dash of E dash, and it is D dash. Next, what about this bottom base points? What about this bottom base points? Bottom base points are, so this is P dash, so this is Q dash of U dash, this is R dash of T dash, and it is S dash. Okay, so what was the base side which is given as? Base side is given which is 25. Okay, so this was a simple position. Now let us, I just consider vertical, you just do horizontal. I just constructed for vertical, okay, and you just do horizontal as your assignment. I just make it my axis vertical. So whatever the vertical means, axis is vertical means base becomes parallel to HP. That means base is parallel to XY. Okay, what are the isometric axis we just have? We already know this. So this was 30 degrees, X, Y, and Z. So for horizontal means which axis are considered? X and Y axis are going to be considered. So I just see that, let us see here. So for that, first of all, what to do? This was a hexagon. I just had to inscribe my box, inscribe my hexagon in a box, right? So this was the box. I inscribe my hexagon in a box. Okay, let us consider this box is let us consider my points. Generally, PQRS is concerned. I just take these points, okay, as PQRS. Now, P, A, B, C, D, E, right? E, F. Let us consider this is G, H, I, and J. This box is my G, H, I, J, okay? Now, I just consider my axis for horizontal 30 degrees, 30 degrees. Okay, so this becomes my G, H, I, and J. This was my box G, H, I, J. I just constructed on 30, 30 isometric axis. Now let us see the points are going to, where the points are, P and C are in between GH, right? So GB as radius, draw an arc, and GC as radius, draw an arc. So this is C. Sorry, this was the bottom points. So bottom points are PQ, RST. So this becomes R. That becomes your R. And this becomes your Q. Next, D point is in between H and I. So this becomes your S. Bottom points are PQ, RST, right? PQ, RSTU. Next. So the points T and U are going to be in between IJ. So this becomes T, this becomes U. Next, the point A is between J and G. So this becomes your P. Now join all the points. PQ, QR, RS, TS, and TU. So the bottom base is obtained. Now I just require my top base. How can you obtain my top base? Again, my top base A, B, C, D is also in between GHIJ. So I just extend my GHIJ for given height 60. GHIJ for the given height 60. Okay. So again, these are also becomes my G H I G. Now let us see the points which are going to be on the top. These points are A, B, C, D, E, F, G, right? So A point is in between. A point is in between J and G. A point is in between J and G. So J as center, J A as radius, you will obtain your point capital A. Next, B, C are in between G and H. So this becomes B, this becomes C. Next, D point in between H and I. So this becomes your D. Next, what are the points in between J and A, J and I, E and F? Okay, so this becomes F, this becomes E. Now join all the points. FE, AB, BC, CD, DE. Okay, top base is obtained, bottom base is obtained. Now I am supposed to join for Prism. What you are going to see? For Prism, you are going to see all the straight edges which are joined to the two consecutive corners. Okay. Now let us see. So A with P, B with Q, C with R, D with S, E with T, F with U, straight edges are to be joined. Okay. Now let us see join P with A. When you join P with A, what is happening? Let us see. What is the condition? We just know no two solid lines can cross each other. So let us see when I drawing this P with A, what is going to happen? Let us see. If I join P with A, actually while I am seeing from the front, PA is visible. Okay. But UT is going to be invisible. So this is going to be dotted. So this was dotted. Why? Because TU is going to be dotted in front of you. Okay. Similarly, the lines which are going to be passing from the farthest, that is UT, are going to be dotted. Let us see. I just join A with P, no problem. B with Q. If I join B with Q also, you just see this TS is also going to be, this was also dotted. Next, C with R. When I join C with R, there should be no problem. C with R. Okay. Next, D with S. D with S is going to be the dotted line. Why? Because if I draw the solid, so it is supposed to cut the top of base edge. So it is going to be dotted. Next, F with U, no problem. Directly I can join F with U. Next, E with T. E with T is going to be like this. Okay, I join all the edges. Okay, so this is when your axis, is vertical or base parallel to HP. So no two solid lines can cross each other. That was the principle. When your solid is going to be lifted 30 degrees, this isometric view is nothing but your solid is just lifted for 30 degrees and you are seeing from the front. When it is going to be seen from the front, you just see all the top base points. So further, all the top base is going to be completely visible. Top base is completely visible. Okay. So that means while you are supposed to join, let us see, PA and DS is directly joined with the DS. Okay, Okay, students, is it clear? Students, is it clear? Yes, someone in this pattern, I just say RS is also going to be dotted. So these three edges are going to be visible. So back edges, those three are going to be dotted. Pawnee. So you just do the problem horizontal as your assignment. Had you copied this? Students, had you copied this? Shall I move to the next problem? Now let us do the problem of a cylinder. Draw the isometric view of cylinder. Draw the isometric view of cylinder of base 50 mm diameter, and 70 mm height and height 70 mm when it is resting with its base on HP. When it is resting with its base on HP. So let us see. First of all, I know the simple position base is resting on HP means XY. Cylinder is going to be considered. Okay. I just divide my circle into 4 number of equal parts. Okay. 5 because for 4 center method. I just consider the points are going to be A, B, C, D, and I just consider it as E, F, G, H. So this is O1 of O2. What was the height of the solid? Height of the solid is given as 70, right? Diameter base 50. Okay. So this was a cylinder, right? For cylinder, we are just highlight only the end generators only. Okay, what are the points? So top base points are A dash, B dash of D dash, C dash. Similarly, here it is E dash, F dash, in bracket it is H dash, here it is G dash. So this is O1 dash, O2 dash. Okay. Now first what should we do? We just inscribe our circle in a box. Box PQRS. P Q R S. So in the problem also he just gives the axis is going to be perpendicular to HP and resting with its base on HP. So that means what was the isometric axis I considered? Which isometric axis is to be considered? X, Y and Z. Which axis is considered? XY is going to be considered. Okay. So let us consider this was P, Q, R, S. Now tell me the points which are going to be on PQRS. So it is the bottom base points are E, F, G, H, right? So in SNP, this point is going to be SNP, the point in between SNP is E, right? So this becomes your E. Next, P and Q, the point is B. Next, R and Q, the point is, sorry. So here it is going to be F. Bottom points are E, F, G, H. So for that only it is G and here it is H. Okay. Now just go for the 4 center method. What was the 4 center method? First of all, we know that. So join P with H, join P with H and G with P. Similarly, join R with E and R with F. So this becomes your O1 and O2. Now this is O1, O2. O1 as center, O1H as radius. O1 as center, O1H as radius, draw an arc. O2 as center, O2G as radius, draw an arc. So let us see. So I join O1 as center, O1H as radius, draw an arc. O2 as center, O2G, draw an arc. Now P as center, PH as radius, PH as radius. Next R as center, RE as radius. You obtain like this. Okay. Next, once you obtain the bottom base, I just require my top base. So which was height of given 70. Sorry. This was 70. Okay. So I just draw the vertical projectors of 70. Okay. Now again this becomes this is P, Q, R, S. So in the top base PQRS points are A, B, C, D, right? Now let us place the points in between the P and S. In between P and S is A. Next, in between P and Q is B. Here it is C and here it is D. Again, the procedure is going to be as same as the previous one. So what was the procedure? Join P with D, P with C. Join R with A and R with B. You obtain the centers O1, O2. Okay. Now O1 has center, OD has radius, draw an arc. O2 has center, OC has radius, draw an arc. Okay. Next again P has center, PD has radius, draw an arc. R has center, RA has radius, draw an arc. Okay. So generally this was a cylinder. While in the cylinder you just highlight only the end generators. So I just highlight the end generators only. I just join these two ends by the two tangent lines which are passing and touching the two ends. Which are touching these two ends. So this becomes the okay. So when you are supposed to see the complete shape like this, so from the first half it is going to be not visible like this. So this base is going to be as like this. Okay. Students, is it clear? You just do when your axis is horizontal. That was your assignment. Students, can I erase this? Can I erase this problem? So draw the isometric view draw the isometric view of pentagonal pyramid of base side 25 mm and height of axis is 60 mm. When its axis is perpendicular to HP and one edge of the base position. So we just enclose our top view in the box PQRS. Okay. So this P Q R S. Okay. Where your A are points A and B. A and B are in between S and P. A and B are in between S and P. So this becomes A and this becomes B. Next, the C point in between P and Q. C. D point in between R and Q. So D. Next, E point in between S and R. Okay. Now join all the points AB. Let us make it with black. AB, CB, BE. Okay. Next. So from the, I just want to make my point O. So let us see from D, I just draw a line, let us see. This OD is going to be the same line which is going to be horizontal, which is parallel to XY. That is parallel to SR and PQ. I just draw a line which is parallel to RS and PQ. I just draw a line. Okay, so from where my point O is going to be obtained, so D as center, DO as radius. D as center, DO as radius. I just place my point. This becomes my O2. Once you obtain your O2, okay, from there I just draw my line vertical. Vertical is nothing but your height of the axis. What is your height of the axis? Height of the axis. What is the height of the axis? We know that. Given height of the axis is 60. From here I just draw the vertical. So I just draw the vertical, which is equal to the vertical axis, which is equal to height of the solid. So this becomes my O1 dash. Okay, let us consider it is O1. Now join all the corners to the apex. All the corners of the base are going to be joined with let us see. So if I join O with A, let us see. O with B, for example. When I join O with B, let us take your O1, O1 with E, O1 with A, O1 with A is going to be obtained like this. Okay, this next O1 with B. Next O1 with C, O1 with D. Similarly, O1 with R is also going to obtain like this. And you just see this idea was going to be and when you see here this A, B, C, these are going to be the so while you are going to see from the front which points are going to be visible, B, C, D are visible. So B, C, D are going to be so somewhere you construct like this. So either this is going to be or this is going to be obtained as going to be the dotted. So D. Okay, like this. Okay, is it clear? So simply what I did in the plane construction, I just do the plane construction, obtain my center O, and from O I just draw the vertical line which is equal to the height of the axis 60. I draw the vertical axis 60, and this is apex, and I just join all the solid lines. So let us see whether the solid and dotted lines are going to be cross each other or not. Okay. So when two solid lines are going to be getting crossing means, so you just make it stop and you just change one of the line to the dotted line. Okay. So here it is nothing but your axis is vertical. So you can do the same problem for axis is horizontal. Can I erase the students? Can I erase it? Similarly, you can do the hexagonal pyramid also. It's the same procedure for hexagonal pyramid also. So let us see a problem of a cone. Draw the isometric view of a cone. Of base 40 diameter and height 60 mm. When it is resting with its base on HP. When it is resting with its base on HP. What was the simple position? You already know the simple positions, right? Base is on HP means top view gives a circle. Okay. So for our convenience, divide your circle into 4 number of equal parts. This is A, B, C, so D. What was the height of the solid which is given? Height of the solid is 60. Okay. So this is O1 of O2. So this is O1 dash, it is O2 dash. For cylinder and cone, you just highlight only the two end generators only. Okay, so this was your base. So these points are A dash, B dash of D dash, and it is C dash. Okay, so once you obtain your circle shape means again you just go for the 4th center method by inscribing your circle in a box PQRS. Okay, so P, Q, R, S. Okay. So base is horizontal means isometric axis is going to be considered. So this is P, Q, R, S, such that the points are going to be in between points or in between S and P. It is going to be A, B, C, D. So let us go for the 4-center method. Karthika, tell me, Amma. 4-center method. Join D with P, join C with B, join R with A, join R with B. Okay, so this becomes your centers O1 and O2. Now O1 has center, OD has radius, draw an arc. O2 has center, OC has radius, draw an arc. P has center, PD has radius, draw an arc. R has center, RE has radius, draw an arc. Okay, and again just got your center, you just draw the line join with C with A. This CA line means parallel to SR and PQ, which is at middle. So these three lines are parallel: SR, AC, PQ. I just draw this line, and A has center, AO has radius. Mark this point. This becomes your. Let us consider this is your center O1. Okay. Now from here you just take your vertical axis is going to be draw the vertical line, which is passing through your axis. So this is going to be your O1 dash. Let us consider it is O1 and it is O2. Okay, for cylinder and cone, you just highlight only the end generators. You just highlight with the join this generator with the join the generator with the okay students. So axis is perpendicular to HP. Simultaneously axis parallel to HP or axis perpendicular to VP. Hello? Students, is it clear? Now, all of you just take the problems in your textbook for developments for this isometric drawings. All of you take the problems. I just dictate the problems. You just tick it or note it down the problem. Problem number 17.16. Problem number 17.16. 17.17. 17.21. 17.21. Okay, 17.26. 17.26. Okay, and okay, you just see those problems. In next class, we will see another 3 or 4 problems which are a combination of solids. That means when a solid is going to be placed one on another. For example, here is a prism and on the top you just place another solid such that the axis will coincide to each other. So that columns are going to be considered as combination of solids. Okay, so that to be seen on the next class. Okay, okay, students. So in next class we will see the combination of solids. Joseph, are you there? Joseph, are you there?